Hello and welcome to the stream. Um, so I've titled this episode Wrapping Up because, yeah, I've decided that I'm not gonna complete the, what do you call it? The whole chess game project here, since most of the work here on out is like something that is just a question of managing details. Of course, I would want to maybe build an AI for it, but since it's not really a project that I will be completing per se, meaning that I won't be making a entire um, what do you call it? I won't be creating, or rather creating a complete chess simulator. As you might recall, this was just a project to get me started on doing stuff here on the channel again. Um, so I think the last things that we would need to do in this project, clean up the state machine behavior, and I want to add some shadow maps. Simple. So that's the general plan. Um, and let's just start out by doing the shadow mapping, and then we will clean up everything. I've decided that this version of the application won't be able to, what do you call it, distinguish between what is supposed to be rendered with shadows and what is not supposed to be. So yeah, we will simply create a pipeline. Since this is ported from our previous project, it already supports a shadow mapping pipeline. And let's do shadow mapping. Shadow mapping. Let's see, we will need the same bytecode, 17. Let's see, and we don't want a render target. Use render target is the next one, false. And then the next one is root signature preset. It will stay the same. I think, let's see, root signature preset, where do we actually use it? Ah, yeah, we definitely want the same amount of parameters. we will change the static sampler section since we need a static sampler for the shadow mapping, of course. Okay, so one is probably fine. And then we have a blend mode. Let's see, blend mode. Let's see, maybe we should just create. Well, we're not using a render target, so I suppose we should just put this as 0, rasterize mode. Okay, so I'm thinking that we would actually want to enable the depth and bias clamp. I'm unsure whether it's on the let's see. Yeah, I'm actually thinking this is supposed to be the standard instead. Like this. Yeah. Yeah. And let's set the rasterize mode to 1 then. Yeah. Okay. Shadow mapping pipeline here. And then a what do you call it? Polygon pipeline. And this is going to be debugging slash line draws. Okay. Okay, let's create a new item here. Vertex shader. Let's call it and let's create a pixel shader. And let's see if everything still runs and compiles. Okay, we definitely swapped something here. Let's see. Oh, wait a minute. We overwrote the the old one. Okay, looks pretty weird. It looks pretty weird. Anyway. Let's see, renderer here. Directx12 pipeline. Shadow mapping pipeline. Let's see. And we're back, up and running. Okay, we have a pipeline. And we didn't need another rect and depth stencil, I think, as far as I remember. Let's see, depth stencil here. We would want something that we could use for our shadow mapping pipeline. So let's build that. Maybe we want something that is actually a shadow map. Okay, let's do that. Directx12 shadow map. We will have a Directx12 resource buffer. And yeah. And let's see. We also want a D3D12 viewport and a D3D12 rect. Scissor rect. Okay. We can experiment with different sizes. Internal buffers. No, we don't want that. Shadow map. And we will, of course, create two. What do you call it? We will create two shadow map, buffer, initialize, device, get. Let's see. Let's do a const expression inside int width. Okay. Okay, let's do that. We will create the buffer. Name shadow map depth buffer. Okay. Okay. And we will be creating a device, create depth stencil view and shadow map buffer get with our same description here, but a different handle. There we go. We will also create a D12 shader resource view description, texture, disk, texture disk, format, ImGUI format, and we will have our R32 float. Let's do a default shader for component mapping, view dimension, a texture 2D, and then let's fill out that most detailed MIP is the first one. The MIP levels are only one of size. Plane slice. 0. This is a float, I think. Yeah. And let's create a shader resource view. Oh, we need more. We don't actually have a SRV heap, I think. Or do we? Constant buffer. Yeah, we do create the what do you call it? The heap here. Mm, yeah, maybe we should reserve the what do you call it? Descriptor heap. Uh, Maybe I just want a separate heap, but we can only bind one at a time, so are we even using it? Pass data, get virtual address, descriptor table, yeah, for the materials, I think. So, if I actually yeah, it's for the materials right now, but yeah, let's just move this. And let's, yeah, we can add sets. Yeah. Mm, we could do something like creating a reserved spaces. Maybe we just increase the right head. No. Oh, wait a minute. So if we manipulate the right head here, we will end up in trouble. Yeah, we need a more elegant solution for this. Yeah, it would simply be offsetting this. M constant buffer SRV. And that's really an ugly name. Let's create a let's just do something like define descriptors reserved. Let's do one. Let's do like that. And let's create a SRV, shader resource view rather. Shadow map buffer.get and the texture disk and the horrible CBV UAV heap get CPU handle 0. Okay, and we update the plus R descriptors reserved. Okay. Let's see. Will this still work then? Everything still works, but now we've reserved the what do you call it? First address of the material, rather the buffer here. Okay. Okay, that's the buffer stuff. Then we do the shadow map dot viewport shadow map viewport top, and set dy shadow map. Let's just do this width as a float. As a float for the height here. All right, and we do the same for the scissor rect here. Let's see, left, top. Right is equal to the viewport dot width, right? Yeah, and the bottom. Let's see, height. Okay, and we have our shadow map. Okay, great stuff. Let's try doing something along the lines of actually drawing the shadow map, or rather to the depth buffer of the shadow map. Yeah, we can share the descriptor heaps here. But this will be for the polygon pipeline. Go. Okay, let's do shadow map, viewport, shadow map, scissor rect. And let's do something. If we have any polygons to draw. This is used for the rest of the thing, so it could still be needed, but this is only if we actually have any polygons to only if we have anything to actually draw. Directx12 command list manager, get graphics list. And I did change that one. Yeah, fine. We're using the API as intended. Okay. Let's set our topology. We will use the same vertex and index buffers. And we will clear our depth stencil view or rather our dev stencil, descriptor handle here, DSV handle. Let's see. Should be one, right? We grab the handle. We tell our graphics command list to please clear the depth stencil at the DSV handle. And a null pointer here. And we will set the render targets. And we set the thing here to the handle as well. So we tell the pipeline that we don't want to render to a render target and we want to render only to a depth stencil. And yeah, we will simply draw the depth information. We don't need anything else but the actual transform. Maybe we should set I'm thinking that we should probably set some pass data. Yeah. Yeah. Right now we will just draw them like any other polygon. Okay. Let's see, we will copy most of this stuff to our vertex shader for our shadow mapper here. But we will only output the position in terms of normalized device coordinates and in terms of world space. Yeah. We could create a different, yeah. So we could just keep this and create a separate buffer. So when we bind this. Whoops. Needs a shadow pass buffer. Yeah, it's already bound in our shader here. So let's just keep that. We don't need this actually. I'm unsure whether our program here will complain. Input here. And let's do output here. Float 4, calculate the position in the world. And let's see, due to the matrix ordering, we do this in the object data transform and a float 4 with the input position here and a extra one to be able to translate. And let's return output and let's rename this also. Yeah. Okay. And let's set our output here, workspace, to our position W, X, Y, Z. And let's transform it into, I don't think it should be called clip space, light space. Yeah, output light space equals small. And we take our pass data view projection and simply pass in our position W. Yeah. Okay. Okay, we have a problem. Unexpected token. Okay. Line 35. Yeah, I think it's this. Okay. Oh yeah. So the problem is now that we set we disable our render target. So up here we need to kind of like we need to move this down here. And we're back. All right. All right. So Thank you, man. Thanks for dropping by, buddy. Okay, and we will create a small shadow map buffer. What's up, buddy? Okay, let's see. We could write it to the same, what do you call it? Yeah, it seems somewhat wasteful to create a 64 kilobyte aligned buffer just to store the past data. Maybe, maybe I just want for the past data buffer here to be containing our stuff. Yeah, it's certainly large enough. You just need to offset by the whole thing. So when we upload our past data here, let's see. Thank you. Okay, so when we upload our draw data here, we could easily create for instance, a XM float 4x4 aligned shadow view, map view projection. Let's see, something like identity XM identity. What's the function? I can't remember. Anyway, let's just do something like this. And let's do the next row. There we go. And we mem copy the to the past data buffer, get memory. Let's see, and convert that into a byte pointer. And we copy the shadow map here. And the size of XM float 4x4 aligned. Okay, so we copy over the view projection matrix here. Okay, so we offset into the buffer here, and we have our view projection matrix here. Okay, we have an error somewhere. Yeah, okay. So it's of course not correctly let's see. We're actually messing up the whole let's do like this. Okay, we have a problem here. Okay, let's see what's the problem. Oh, maybe it's not big enough or what. There we go. So it was just too small. Okay, so the next constant buffer in the buffer will be our shadow map information. And we bind it whenever we want to. Whenever we want to draw the actual shadow map, we bind it back to the polygon pipeline. Okay, let's see. Okay, let's see. Let's see, can't I? Let's see, said. Let's see. Mm, let's see, issue. View contents. Not that one. Oh yeah, maybe. We need to actually create a, what do you call it? Okay. And let's just do a, yeah. We probably need the, yeah, we need to actually calculate the shadow map view projection matrix. Let's see. I think I think I need to um maybe actually maybe I made a mistake here inside the pipeline state. Yeah, I think this is separate for the shadow mapping. Rasterize mode is the last one, which is this one. Yeah. Okay. And we need an orthographic. What's up, buddy? Welcome. We need an orthographic um what do you call it? Yeah, let's hard code it for now. Okay. Calculate uh, uh, and store the view projection matrix of the sun. Let's quote it. Okay. Right now it's hard-coded. Stuff is hard-coded. Let's see, inside our pixel shader here, we have a hard-coded light direction, right? Yeah, we do. Let's see. Inside the polygon pixel shader. Okay. Let's do an XM vector direction. 0, -1, -1, 0. Let's see. Sun light position, which will be in the opposite direction of the direction. And some radius. Let's just do 100. Const expression float scene radius. And let's do a XM vector scene center. Let's just set it to 0. Here we go. Okay, let's create a XM matrix of the view matrix light. And we pass in the light position, the scene center, and the a up vector for the light, which will be 0, 1, 0, and 0 here. And we need a orthographic function here. No, not left hand, right hand here. Uh, okay, XM matrix projection projection matrix light is equal to the okay. So we will seed radius negative, and then U positive. Let's just copy this. That's the X coordinates. Then we have the bottom, which is the negative, right? Yeah, and then we have the top, which is the positive, and then we set a small near and a large far plane. Let's just do that. XM matrix VP light U times the projection here. There we go. So we upload that. Let's see if we actually compile. We don't. Why is that? Did I miss something? Maybe I did. Uh, did I cut out something else inside this? I might have. Huh? I missed something up here. Alright. Alright. Oh, there's another one there. Okay. So that's the problem. Let's see. There we go. Let's see if this changed anything in terms of our. Let's see. Okay, we do have something else here then. I'm pretty sure we'll have to mess around with this. Yeah, so as you can see, we are definitely building a depth buffer here. But I'm definitely thinking the parameters are bad. Okay. We have a funny little guy here. Okay. Okay, so the center is of course not um, the origin anymore. I think each tile is each tile is 2, I think, in size. So let's do something like this instead. All right. Okay, So as you can see here from the light perspective, the scene kind of looks like this. Yeah. Okay. So we have our depth map. We could play around with the whole setup, of course. But yeah, I'm gonna. Yeah, I'm gonna go eat and maybe I'll finish up the whole stuff here on stream. Anyway, we at least got started on the shadow mapping. Yeah, you could definitely play around with the settings and yeah, maybe if we. Yeah, anyway, I'm gonna end the stream here. Hopefully you found it helpful. Anyway, next steps are to sample the shadow map and use it in our polygon shader to render the shadows. You could of course play around with all of this stuff here. In terms of settings, it basically creates a view and a projection matrix for the uh, directional light, which is our sun, quote unquote, and uh, calculates a matrix from which it's possible to render the whole scene from the perspective of the light. It's orthographic, it's not with a regular perspective, which means that it treats every ray cast as completely not diagonal, perpendicular to each other. So perpendicular is it? No, well, yeah, at least going in the same direction. All of the light rays go in the same direction because the sun is so far from Earth. It looks that way, but yeah. Anyway, we have basic shadow mapping. We only need to implement the shaders and bind it. Yeah, okay. But thanks for tuning in. I'll probably end this in another episode before I move on to my next project. All right. Thanks for tuning in. Feel free to comment, like, or subscribe. Follow the channel or anything of the like. All right.